Okay, I want to do an example with you of another one with a bullet and a hanging pendulum, because you're going to encounter some that have an extra step that you haven't seen yet. So I'd like to do one of those before you try the next suggested problems. So we have our ballistic pendulum again, and its mass is 1.75 kilograms. And we have our little bullet again being fired at it, and the little bullet's mass is 5.5 grams. And again, we don't know the mass of the bullet. Okay? But we know that after the bullet hits the pendulum, it sticks and stays. So it's stuck in here. And the bullet and the pendulum swing up. So it sounds like the one we've already done. But here's where it's different. Because what you're going to be told is that it swings up to an angle of 21.6 degrees. Now, the other thing that you're told in the question is that the full length of the pendulum string is 178 centimeters. Now, we always call the height where the pendulum starts down here, we call this height 0. And so its change in height will really be its HF, which is what we want when we do the energy piece. Now, before I get ahead of myself, there'll be two parts. There'll be the collision, which is momentum, and then there'll be the swinging up part, which will be energy. Okay? But before we can do that, we don't know VI of the bullet, and we don't know how high up it swung. But we can find how high up it swung from this angle. Because if you draw a dashed line in here, you can form a right angle triangle. Okay, this is my HF, the part below the triangle to the pendulum. The part on the side of the triangle here, we could call Y. We know the length of the pendulum. It's 178 centimeters, the length of the string. So we know the hypotenuse, we know the angle, we can get our Y. The Y is the adjacent side, so it would be cosine. So cos of 21.6 is equal to Y over 178. And we can find our Y. So cos times 178. And we get our Y to be 165.5 centimeters. Now this is not our height. Our height is the rest of this length. Okay? And remember, this whole thing is 178 because this is also the length of the pendulum, right? So our height final is going to be the length of the pendulum minus our Y. In other words, it's going to be 178 minus 165.5. So our height final, and these are centimeters, is going to be 12.5 centimeters. Then once we have this, now we can go to our energy. And we can say, okay, 1/2 mv initial squared plus mgh initial, squared, plus 1/2 kx initial squared should equal 1/2 mv final squared mgh final plus 1/2 kx final squared plus E lost. And there's never any E lost in pendulums. And there's no spring. So initially, before it began to swing up, it had a speed but no height. Finally, when it reached its highest spot, it doesn't have a speed, but it has a height. So we're left with 1/2 mv initial squared equals mgh final. What are the m's? Well, in both cases, it's the block of the pendulum, ballistic pendulum with the bullet embedded. So the m's cancel. And we're looking for the speed with which the pendulum and bullet swung up. So multiply both sides by 2. 2GHF. 2 times 9.81 meters per second squared times the 12.5 centimeters has to change to meters because I have a meters in my G. So 0.125 meters. And remember, you need to take the square root there because it's VF squared. So times 9.81 times, or VI squared times 2. Take the square root. I get 1.566. 1.566 meters per second. Okay? So that's the speed with which the bullet pendulum together swing up. So now I come over here to my momentum. M of the bullet, V of the bullet initial, plus M of the pendulum, V of the pendulum initial, equals M of the bullet plus M of the pendulum, V final. This V that I just found is my V final. The pendulum wasn't moving initially. I can now find the speed of my bullet. So M of the bullet plus M of the pendulum, V final, divided by M of the bullet. So V of the bullet initial. Bullet's mass, 5.5 grams, so 0.0055 kilograms, plus 1.75 kilograms, times this 1.566 meters per second that you just found, divided by 0.0055 kilograms. V of the bullet initial equals, so times bracket 0.0055 plus 1.75 divided by 0.0055. I get 499. I was aiming for 500. 499.8534 meters per second. Okay, which again is what makes bullets dangerous. All right, so the only new little piece is the angle. So you swing the pendulum out, and then you create a right angle triangle, allowing you to find the adjacent side by using cosine. And then once you have that much of the side, take it away from the full length, the 178, to get the piece that must be the height. And then you just go back to the normal question. Okay? So tonight, suggested questions, page 524, numbers 44 and 45, and on your sheet, number 5 and number 6 on the sheet. Okay? Thank you.